Hi, everybody. This is Mr. Folly again, and welcome to Titrations. Yes, we do get to do a real lab in here. So, welcome and get ready. We're going to show you the math and go over the basics of how to do it. So, a titration. A titration is a laboratory technique used to precisely measure the molar concentration of an unknown solution using a known concentration of a different solution. Math. XMAVA equals XMDVB. Those of you who are non-believers out there and you go to like Khan Academy or whatever, this is a Mr. Folly special. This X thing. I did this because people often forget about the X part, and I'll show you that. If you remember from before, moles equals MV. So if we're thinking about this, we really have moles equals moles when we say MV equals MV. Okay, so what that also means is if we get really mean to you, another way to do moles is mass over molar mass equals big MV. So you can titrate a solid. Isn't that weird? You can titrate a solid. Can titrate a solid. You would dissolve it in water, but still. So what are these X's? X is the number of H's in the acid. So if I'm looking at H2SO4, there's two H's in H2SO4, so X is 2. If I'm looking at HCl, there's one H, so X is 1. X is the number of OH's in the base. NaOH has X equal 1 because there's one OH, but BaOH taken twice would have 2 because there's two OH's. Ma is the molarity of the acid, Va is the volume of the acid, Mb is the volume of the base, Vb is the volume of the base. Honesty time here. I just write XMV equals XMV, and I always do the acid on the left and the base on the right. You just can't mess it up. It's the only thing. Let's do some examples. Determine the molarity of 25 milliliters NaOH. Hey, that's a base. That's a volume. If it takes 10 milliliters of 0.2 molar HCl, that's a volume. That's a molarity. That's an acid to completely neutralize it. So neutralizing tells me I'm going to do that, and titration tells me I'm going to use my XMV equals XMV. So I'm going to write XMV equals XMV because you know I love to write it down. My acid is this side. Okay, can you tell these are the acid parts? Let me read it again. Determine the molarity of 25 milliliters of NaOH if it takes 10 milliliters of 2 molar HCl to completely neutralize it. So this milliliters, these milliliters, and molarity are going to be my acid. So how many H's are in HCl? Well, we're in an accelerated class. I'm not going to say that out loud. But yeah, I am. It's 1. So my molarity is 2, and my volume is 10, equals how many OH's in NaOH? Hey, that's 1. I've got a volume, but I don't have a molarity, so I'm going to write M. I'm going to, put 25 for it. Now, most of our lives in chemistry we're being tortured with units, right? So notice how in this case we used milliliters on both sides. As long as the units are the same on both sides, it's good and it's fine. But if they're not the same, then you're going to make them the same, and I recommend liters in that case. So now I'm going to solve for molarity. So I'm going to multiply this left-hand side out. So 0.2 times 10 is 2. And then I'm going to divide it by this side, divided by 25. Now, I didn't show you multiplying or dividing by 1 because it doesn't do anything. Just like, what is it that happens if you do that? Just like kissing your sister. So that's M, which is going to be 0.08. Now, notice I've got 3 sig figs. I've got 4. I've got 4. So I need 3.0800 molar of base. So now, wouldn't be chemistry if there wasn't a little trick to it. So this one's a little bit different. Determine the molarity of H2SO4 at 15.35 milliliters of H2SO4. I'm looking at the acid there. Is neutralized by 16.44 milliliters of 0.055 molar solution. Uh-oh, I lost my word for solution. My solution is going to be KOH. I hope you don't mind me inserting that in there. So it should be KOH solution. So XMV equals XMV. XMV equals XMV. Remember, acid's on the left, base is on the right. How many H's in H2SO4? 2. My X is 2. What's the molarity of my H2SO4? That's what I'm determining. So it's M. So again, just to read that. Determine the molarity of H2SO4. That's why M is my unknown. Okay. If 15.35 milliliters of H2SO4, that's my volume, 15.35, I think I misread that before, equals how many OHs and KOH? Just one. What's the molarity of my KOH? 0.550. What's the volume of my base? 16.44 milliliters, just to make sure. Got volume on both sides. They're both in milliliters, so that's yummy. So then I'm going to solve for it. So molarity is going to be 0.55 times 16.44 divided by 2 divided by 15.35. And I'm going to throw 3 sig figs up there when I get it. 0.55 times 16.44 divided by 2 divided by 15.35. And I get 0.294. 0.295 molar K. Oh, whoop. Nope, that's H2SO4. Come on, pen. A molar H2SO4. All right, so that's the math part. That's going to say the harder part. Let's take a look at what titration really is. So titration is a lab technique. Let's see how we actually do this. All right, so this long glass dude right here is called a burette. Okay, so your burette is going to have an initial reading. So I've got a number that I'm going to read right here. I have a burette clamp that holds it on there. What a great naming thing. I have a stopcock which opens and closes it. I have a stand which holds my burette clamp. And I have a flask. Remember, flasks have slanty sides. Okay. We are not going to quiz you on which one's the titrant and which one's the analyte. Okay. Titrant does the titration, but you don't need to worry about that. Okay. So how do we do it? We put the known solution in the burette and record to 2 decimal places. So if I'm looking up here and this guy's, woo, this might be like 1.22 milliliters. Put the unknown molarity of a known volume in the flask below. So I would intentionally put in here exactly 10.00 milliliters of question mark molarity acid. Okay. Add 2 to 3 drops of indicator. That's to the flask. So that way it'll change colors as soon as we've reached our equivalence point. Add 1 to 2 drops of known at a time until a persistent color change occurs. So here's the tricky part. You want to know which single drop makes it change color. So if you drop 1 drop of, I go bloop, 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 and that's the one that makes it change color. Notice how this is a light color. My colorblind self can tell that. And this is a dark color. And I want to know exactly which drop makes that change color and stay that color. And then you record the final volume. Then you do the calculations we just did, and you do the dance of joy. And that's it. And I will say, toodles.